Alright, let's talk about what we do when we have a weak, try that again, a weak acid. Mono meaning one hydrogen given off, like HCl is a monoproduct. H2SO4 is not. This is diprotic because there's two H's possible to come off. But we're talking about one right now. General equation, like I could insert HCl here. Yes, HX plus water gives H3O plus something else. Let's just call it X minus. Now, if I write KEQ for this reaction, I would get products over reactants. Exponents are the coefficients. 1, 1, 1, and 1 means 1, 1, 1, and 1. Now, we have discussed already that H2O, the concentration of H2O is pretty much constant. Yes? So, if I take H2O, I multiply both sides of this equation by H2O, it would appear over here, it disappears from here. Now, this is a constant, and we just learned before that the concentration of H2O is constant, so a constant times a constant is another constant, and since we're talking about acids, we use the symbol Ka. So, let's try a question using this formula. So, black. It says calculate the concentration of H3O plus and the pH of a 0.1 molar solution of acetic acid, 25 degrees Celsius, and it gives me the Ka. So this is an equilibrium question. Well, what do we do to solve equilibrium questions? We make ourselves a chart. Yes. Let's do that and that and that. All right, we're ready to fill it in. So initially, what do we know about in these questions about the concentrations of H2O? We already wrote it's pretty much constant. The initial and the final will be pretty much the same value, so such a small change, we're not even going to talk about it. So what I like to do is I like to put, I'm going to write in blue, I like to put a great big X through this because I don't care about it. It's not changing. I'm only interested in these other three things. The initial concentration of CH3COH is 0.1. Yes? The initial concentration of H3O plus is 0 and 0. How much of this stuff am I going to make? X and X, and this one is going to get smaller by X. Why did I choose X, X, X? Because the coefficients are 1, 1, and 1. So the final will be X, X, and 0.1 minus X. Now, let's write the expression for Ka for this. It's going to be H3O plus CH3COO minus over CH3COOH. No water. You see that in the Ka formula above, and we see it here because I crossed it out. One sec, let's just make sure that we remember what the value for Ka. Ka is 1.8 times 10 to the minus 5. 1.8 times 10 to the minus 5. over 0.1 minus x. Now, you can charge ahead and swing this over, multiply this times this times this. I have an x squared, I'll have an x term, I'll have a number, it's a quadratic, I can use the quadratic equation, blah 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 blah, everything's fine. Or you could stop right at this moment and say, wait a second, Ka is pretty small, hold up, let's see. Yes, the initial concentration divided by Ka is going to be 0.1 divided by 1.8 times 10 to the minus 5. Now, that is like 5,000. It is definitely bigger than 1,000. So what does that mean? That means x is small. So I'm going to use an approximation here to solve this and make the math easier. Am I going to do something about the top if x is small? No. Am I going to do something at the bottom if x is small? Yes. 0.1 minus x, a big number, minus a small number, is approximately equal to the big number. Yes? So, remember on a test, this is going to be worth a mark. 1.8 times 10 to the minus 5 is equal to x squared over 0.1. X squared is equal to 1.8 times 10 to the minus 6. X is the square root of 1.8 times 10 to the minus 6. Yes? And I'm going to get a value here for x. Now the question asks us for two things. Concentration of H3O plus, right here. Oh, it's x. I just found it. A, check. pH. I need to find pH. And that's really the difference here between this and normal KEQ questions. I have this pH that I can swing in, another concept that I can swing in here. I actually don't have a calculator with me right now. I don't know what this number is, but whatever it is, that's A. That is equal to the concentration of H3O plus. Now I also need to find pH, and I know pH is equal to negative log concentration of H3O plus. So I'm going to get the negative log of whatever this number is. Yes. And I'm going to get a pH, and it's going to be definitely will be smaller than 7, because this is an acidic solution. If I don't get an answer smaller than 7, something has gone wrong somewhere. So that's Ka in a nutshell, and now you can try some questions on your own.